Hello everyone and welcome to Machine Learning, Large Language Model and AI tutorials. In this Machine Learning and AI tutorial, we explain how to create a simple DeepSeek R1 application and a graphics user interface or GUI and how to run this application locally on a Linux Ubuntu computer. The application is developed in Python by using DeepSeek R1, Ollama and Streamlit. For those of you who are not familiar with DeepSeek, DeepSeek R1 belongs to the class of reasoning models. Reasoning models perform better at complex reasoning problems and tasks compared to the classical large language models. Complex reasoning problems are problems that appear in math, science, and coding. According to the information given on the GitHub page of DeepSeek, the performance of DeepSeek R1 is comparable to the performance of OpenAI O1. However, DeepSeek R1 is released under the MIT license, which means that you can also use this model in a commercial setting. In this tutorial, we present a proof of concept for building a desktop application that's based on DeepSeek R1. The application is deliberately kept as simple as possible in order not to blur the main ideas with too many complex programming details. You can use this tutorial as the basis and as the starting point for the development of your own applications that integrate AI, graphics, sound, animation, etc. What is most important, the application will run on your local computer and it will run in your web browser. It's simple as that. We are using Streamlit to develop the graphics user interface and to embed the AI model. Streamlit is an open source Python framework for quickly creating interactive data applications. Streamlit is designed for data scientists and machine learning engineers. You can quickly learn how to use this framework and you don't need to have a front-end development experience, you don't need to know Java, you don't need to work like 15 years developing website, applications and graphics user interface. Streamlit is very simple and literally in 15 lines of code you can generate your first application. Of course, to generate something more useful, it's going to take some time learning Streamlit. The solution presented in this tutorial is a quick and dirty solution. In the future video tutorials, we will delve deeper into the AI app development. Let's first explain what are the distilled models. To run the full DeepSeek R1 model locally, you need more than 4 or even 500 or even more gigabytes of disk space and a significant amount of CPU, GPU, and RAM resources. And this might be prohibitive on the consumer level hardware and for us mortals who cannot afford a computer that costs $100,000. However, DeepSeek has shown that it's possible to reduce the size of the original DeepSeek R1 model and at the same time preserve the performance. Of course, the performance is not completely preserved by reducing the size of the model. However, the performance is still not bad. Consequently, DeepSeek has released a number of compressed, or how they like to call it in a fancy word, distilled models whose size varies from 1.5 to 70B parameters. To install these models, you will need from 1 to 40 GB of disk space. In this tutorial, we will explain how to install and run distilled models of DeepSeek R1. And here are computer specifications. We are having NVIDIA 3090 GPU, 64 GB of regular RAM, Intel i9 processor, 10850K, that's the processor number, which has 10 cores and 20 logical processors, and we are running the model on Linux Ubuntu 24.04. So let's immediately start. Okay, so let's immediately start. The first step is to install Ollama. To install Ollama, first click here, then search for terminal, open a terminal, and I'm going to resize this terminal such that you can see what I'm typing and at the same time you can see the commands over here. Whenever you want to install a program on Linux Ubuntu or a package, you need to run these two commands which are compressed into a single command. These two commands will update and upgrade your system, or better to say packages, not the system but packages. So consequently, wait for a while until this command is being executed. And click on yes. The next step is to install curl. We will need curl to run remote scripts and to download Ollama. Then let's verify that curl is properly installed by executing this command. And if you see the response that looks like this, let me just wait for a while. That is, if you see this type of response, this means that curl is properly installed on your system. The next step is to allow inbound connections to this port over here. That is, the port is given here. So enter here. Don't worry, over here you're not opening this port to external computers or external users. You're just opening this port internally such that Ollama can connect to this port given over here. Okay, let's proceed further. The next step is to download Ollama. How to download Ollama? Well, to download Ollama, you need to go to the Ollama website. Here it is. And then you need to click on download. Then you can see that automatically my operating system is recognized as Linux. So here, copy this command, go back to the command prompt and simply execute this command. This command will use curl and it's going to execute this installation script. And here it is. Now here you need to be patient since it's going to take a while to download and install Ollama. The next step is to verify the installation of Ollama. To do that, simply type Ollama. And over here, you can see that Ollama can be called, which means that Ollama is successfully installed on your system. Next, let's download the model. Go back to the Ollama website. Let's do it like here. And then over here, let's search for model DeepSeek R1. And click on this link and let's explain what is written over here. Over here, you have several options. Namely, if you click here, you will see all the possible models. However, note that the model starting from 1.5b until 70b is a distilled model. What a distilled model means? This means that the model is reduced. However, at the same time, the performance is slightly decreased. In this video tutorial, I'm going to select this model. However, you can select any other model. Then, this command will be generated. So copy this command. However, paste it here and don't immediately execute it. Change run to pull. I'm doing this since I just want to download the model. I don't want to download and run. I will run the model later on. And press enter. And over here you need to be patient since it's going to take around 5 minutes or so to download the model. And after the model is downloaded, you should see this success message. Next, let's learn how to run the model. First of all, let's verify that the model is on our system. We can do it like this, and you can see the model. To run the model, copy this and type Ollama, run, and then the name of the model. And here you are. It's going to take a while to load the model. Here we are, and let's test how to solve a quadratic equation. And let's set the quadratic equation x squared plus 2 times x is 0. This should be super easy, and here it is. Bang! It works like a charm. Very fast. Good. Let's exit the model. Control D to exit the model. The next step is to create a Python workspace folder, then to create a Python virtual environment and install the necessary libraries. So let's learn how to do that. First of all, let's make sure that we have Python installed on our system. To do that, type this, which Python 3, and as the result, you should see the path to the installation folder of Python. Good. Let's now verify the Python version. And you can see in my case, I'm using Python 3.12. Here's one very important remark. Namely, Python should come together with Ubuntu Linux 22.04 and 20 4.04 as well as with other versions. Consequently, you don't need to install Python on your system. Next, let's create a workspace folder. Let's go to the home folder, then let's type this to create a folder called test app. Then let's navigate to test app, and inside of this folder, let's first make sure that we have a command for creating Python virtual environments. You need to execute this. And after that, let's create a Python virtual environment. You need to execute this command. And after that, we need to activate the Python virtual environment by executing this command. And as the result, you should see in parentheses environment 1. This means that we are currently in our Python virtual environment. And let's install the necessary libraries. We just need 2 libraries, however, they have multiple packages inside of them. Or maybe Ollama is a package and inside you have libraries. I'm not sure how do you call it. Do you really say like a library or a package? However, you know what I'm saying. So let's first install Ollama. Ollama enables us to call the Ollama model from a Python code. And the next step is to install Streamlit. So let's do that. Streamlit actually installs a number of packages. NumPy, Panda, and similar things. So I will later show you how to verify that you have all the packages. Okay, if you type now pip list, you can see what these 2 commands had installed. This is insane. You can see all these packages are here. Good. The next step is to write the Python code that will implement our application. Consequently, execute this command or you use some other Python editor. Here we are. And here, to save time, I'm simply going to paste the code. Here it is. And let's explain this code line by line. From here to here are comments. Then I need to import the necessary libraries. First of all, I need to import Streamlit as st, and here I'm importing Ollama. Here I'm defining the model name. Here is the model name. Note that this model name should precisely match the model name returned by the command Ollama list. And here it is. Next, I need to set the title of my application. Here I'm saying LLM application based on DeepSeek R1. And you will see later on, once I run the application, where this title will appear. Here is the main part of our code. This function will receive a question that we want to ask, and it will generate the response. So what's happening inside? Inside of this function, we are passing this function, actually this question, to Ollama model. And we do it over here. We call ollama.chat. This function will call the model. We specify the model name, and here we specify the message. What is our role? Our role is the user, and here's the content. The content is question to ask. And then what happens after that? We write st.info, and over here we extract the response. That is, ollama.chat will return a data structure, and in order to extract the response in the form of the string, we need to type this. And we type simply st.info. This function will actually print the response in appropriate display or a form on our website, or better to say on our application. And over here is another very important part. With st.form, my form, this is how we call it, we do the following. First of all, we generate a text area. So in the text area, a user will enter its text. For example, here in the text area, you will type the question, as you will see later on. Then, what do? We create a button. We create a submit button. Here it is. And if a user press submit button, the question that's written over here, or actually that's entered by the user, will be passed to this function over here. That is, it will be passed to generate response. And we do it like this. That is, if the button is being pressed, submitted becomes true, and if true, then we simply call the function generate response and we pass the text. The text over here is the text that's being read from the form, and you will see it in a minute. And that's it, simple as that. Let's save this file by pressing Ctrl S or Ctrl O, and let's press Enter to save it. And let's press Ctrl X. The next step is to run this application. To run this application, we simply need to execute this command, Streamlit run, with the name of the file. Let's verify the file exists. Let's do this, and bang. Here, welcome to Streamlit. Just skip this part, and here it is. Voila! So look what happened. Automatically, a browser is being opened, and you see where it's being opened. It's being opened on this local address. Then you have the local address and you have the network address. So this is the local address that can be accessed from my computer. This is the address that can be accessed from another computer. Okay, so let's see over here, and let's go back and let's look into the code. So I will click here, then I will go home, then I'll go test app, then I'm going to open up in a text editor over here, and let's see what's happening. First of all, let's go back to this form and let's look into our app. So you can see enter text over here, ask a question and press the submit button. And if you go over here, you can see that this part creates this part over here. You enter here the default text. That's it, right? And once I enter anything over here, what will happen? The text will be filled. That is, the string will be filled or created. So let's write a question. How to create, no, better to say how to solve a quadratic equation. And then let's specify x squared plus 2x is 0. Okay, once I click on submit, let's see what will happen. So once I click on submit, st.form submit button submit will return true. And if true, then what will happen? I need to generate a response. That is, the function generate response is called. The text written over here is passed to this function generate response. And let's see what the function will do. So you have question to ask, you specify desired model. Over here you pass the question. Here you call the model is called in the background, and response is being filled, and you simply retrieve the response and you print it out. Where? Well, you will print it out in a new form that will be created over here. So let's click on submit and let's see what's happening. Now, as you can see here, the model is running, and here it is. Literally in several seconds, the response is generated, and that's it. Simple, simple, simple as that. And that's it. And then let's try it again. How to cook a nice meal made of, let's put for example, meat, bread, and cheese. Let's see what will happen. And then submit, and then the model will be run again, and you can see, let's see what the model will give us. This is very funny. Now again, it takes time since this is a little bit more complex question. However, I can see that my GPU is working, and here's the response. Very good. So you can even learn how to cook by using this large language model. Okay, that's all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons, and see you in the next video tutorial.